All right, we're going to jump into a quick review of area of polygons here. So this is stuff that you've probably seen before, but just want to touch base because it's going to come up in our current unit when we look at surface area and lateral area of three-dimensional figures. You'll need to remember the area of these two-dimensional figures. So just real quick, starting with some basic ones, we've got a rectangle here, so the area of a rectangle is going to be length times width, so that's just side times side there. And then moving down below to the triangle, okay, we've got the area of this triangle is going to be 1/2 base times the height. And then to the circle, area is going to be pi r squared. And then I wanted to review a couple of things down at the bottom. First, a regular polygon. That's a term that they're going to use. They call it a regular polygon. And that means that all the side lengths are the same length. So all the side lengths are congruent, and also all the angle measurements are congruent, but we won't really use that here. But for our purposes in this unit, you'll need to know if it's a regular polygon, then that implies that all the side lengths are the same. And then we've got right triangles. Just wanted to refresh your brain on the Pythagorean theorem, right? A squared plus b squared equals c squared, where c is the hypotenuse, right? That's the longest side opposite the 90-degree angle. So just refresher on that as well. Okay. We'll jump through a couple of these. It says find the area of the regular polygon. So key here is that it states that these are regular polygons. All right, so then that implies that all of the side lengths are the same. So on this first one here, right, we've got this rectangle, and since it's a regular polygon, we can say, okay, well, that means this side here is also 6, so it actually turns out to be a square. And so then to find the area here, I can just do area equals side times side, which is 6 times 6, which gives me 36, and this would be 36 units squared. They don't give us any units here, right, but this would be units squared here. All right, and so that's good for the area of that square. Scrolling down below, we've got letter B here. We've got this triangle, okay? And since this is a regular polygon, we know that all of these side lengths are the same, right? Each one of these side lengths is congruent. And we've got the base there at 4, and we've got the height at 3, and that's all I need to know here. So it's going to be area equals 1/2 base, which is 4, times height, which is 3. And so then that's just going to give me a total of 6. So this would be 6 units squared, 6 square units here. All right, scrolling down to letter C. Letter C gives us a circle, and then it gives us a diameter. Remember that the area for our circle is going to be area equals pi r squared, where r is the radius. Well, they gave us the whole diameter, but we can quickly figure out that the radius would only be half that much. So then that's just going to be area equals pi times 5 squared, which gives me the area equal to 25 pi, and you can leave it in terms of pi, and so we don't need to evaluate that using the decimal, and so that's going to end up being our area there, 25. All right, moving to letter D here, we've got another triangle, right? We got one side length is 4, and since these are regular polygons, we know that means that all of the side lengths are 4, so I'll go ahead and fill that in here. We know side lengths are 4. The problem for this one is we don't know what the height is, right? So the height going up and down here, we don't know what that height is of this triangle, but what we can say is that since this is a regular polygon, this height is going to come right down the middle there. And so this is just going to be a measurement of 2 right here. Okay, that's halfway through the triangle, right? And so then we can use our Pythagorean theorem here to find the height, because we've got a right triangle. Let me go ahead and outline it so you can see what I'm talking about here. Okay, we've got this right triangle right there. Okay, and so I can say that 2 squared plus the height squared equals the hypotenuse squared, which is 4. So I'm going to go ahead and say, all right, 2 squared plus, we'll call that h squared, equals 4 squared. And so then I'm going to have 4 plus h squared equals 16, subtract 4 from both sides, so I get h squared equals 12. And then I'm going to have to take the square root of both sides, so h equals the square root of 12. All right, and so I know that the height now is going to be the square root of 12. Right there. And so then when I use my area formula, going back to find the area of the entire triangle, I can say area equals 1/2 the base, the entire base, which is 4, times the height, which is the square root of 12. And I'm just going to simplify that a little bit to be 2 square root of 12. And I'll leave it with the square root there so I don't evaluate it into a decimal. So we just had to do a little extra work to use Pythagorean theorem to figure out what the height of that triangle was going to be there. All right. Moving down to letter E, we've got a half circle here, semicircle, half circle. And so we, again, can use our area formula of a circle, which is pi r squared. But then since it's only half the circle, I'm going to divide that all by 2. Once again, they give us the whole diameter, and so I know that the radius is going to be half as much, which is only going to be 4, and so then I'm just going to punch this in here. It's going to be pi times 4 squared all over 2, and so I end up with an area of 16 pi over 2, which gives me 8 pi square units. All right, and now I wanted to review a couple of three-dimensional shapes with you that we're going to see in the next couple of lessons here. So this might be something that would be good, I don't know, to print out or save somewhere so that you have these next to you, because these are going to be important for us as we move forward. The first one is a pyramid, and I highlighted here that pyramids come to a point at the top, so that's a way to remember that it's a pyramid. And then we can describe them even further based on what their base looks like. So notice that for this one, we've got a triangle as the base, right? We've got a triangle as the base here, which makes this a triangular pyramid. Because we know it's a pyramid because it comes to a point there, but since the base is a triangle, we can be more specific and call this a triangular pyramid. And then if we scroll over to the other side, again, comes to a point here, so we know it's a pyramid. But if you check out the base here, right, if we look at the base is a rectangle. It looks kind of like a square, but we can't be sure. So we'll call this a rectangular pyramid. All right, moving on. We'll look at these prisms, and prisms are a solid object with 2 identical ends and then flat sides. And we name these prisms based on what their identical ends are, whatever their identical ends are. So if I'm looking at the first one here, we've got these identical ends, which again are rectangles. So this would be a rectangular prism. And then we'll move to the next one here. Same idea, we've got the flat sides and the opposite identical sides are triangles in this case. And so this would be a triangular prism. And then we can move over to this next one here. And we check out what the opposite sides are for this one. Highlight this, and it looks like these are 6 sides here. So remember, 6 sides is a hexagon. And so this is going to be a hexagonal prism. And so we name these prisms based on those identical ends there, right? We could have a pentagonal prism if there were pentagons there. It just depends on whatever the shapes are on the ends there. All right, we keep moving here to two more. We've got a cone. A cone comes to a point with a circular base, right? So it's kind of like the pyramid, it has the point there, but then it's a circular base, so that's a cone. You've seen that before, I'm sure. And then also a cylinder. This is the top and the bottom are circles, right? So in this case, we've got circles on the top and the bottom, so identical, but they are circles, so that makes it a cylinder. And we'll talk about all of the ways to find measurements for these 3D shapes in the coming lessons. All right, thanks for watching.